Salam everyone. I hope you all are well. So finally in this video we will be covering applications of integration, such as we will look into how to find the area of how to find the area when a function is integrated. Alright, so let's begin. Finding area using the integration process. Now if you have a function which you need to integrate from a to b, the integration of a function gives you area under the curve. If let's say this function was integrated with respect to x, so this will give you the area of a function area between the function and the x-axis when it is integrated from limits a and b. So this is the region that we are looking at. So integration is also a process of the summation. If you can visualize this as breaking up this entire portion into smaller and smaller rectangles such that the width of each rectangle is delta x and the height is the value of the function itself. Okay, so when you add all these small rectangles, you will get an approximate value of the area of this shaded region. Now do you see this? These small parts are being left, so that is why adding these rectangles will give you an approximate area. But when you integrate a function from the limit a to b, you will get the entire exact area. So if you are asked to find the area between the curve y equals to f of x, where f of x is a function of x, and the x-axis bounded by the line x equals to a and the line x equals to b, the area of this region is given by integration of this function from with lower limit a, upper limit b, and you will integrate it with respect to dx. Okay, so this is how you can write it, and then the following integration process will follow. Also, if you are being asked to find the area between the curve f of y, x equals to f of y, the y-axis, and the line y equals to a and y equals to b, which means, let's say you have this function and you are being asked to integrate the function with respect to y. So first thing that you need to have is the function in y. So whatever the equation of this function was, you need to make x the subject so that this function can come in this function can become function of y. Now you need to integrate it from here to here. So this is the region that we need to find the area for. So integration of f of y from this lower limit to upper limit with respect to y-axis. So this is the area bounded by the curve and the y-axis and line x equals to a and y equals to a and y equals to b. Over here it was a region bounded by the curve and the x-axis and the line y equals to a and y equals to b. So in this the lower limit was a and the upper limit was b. Similarly यहाँ पे भी lower limit would be a and upper limit would be b. But you need to remember that now you need to make a function of y. So in this question you are being asked to find the area bounded by the curve y equals to x square plus 1, the line x equals to minus 1, the line x equals to 3, and the x-axis. So this is how a y equals to x square curve would look like. X square plus 1. So this point is 1. ठीक है, you need to find the area bounded by the curve. This is y of x or the function in x. You need to find the area bounded by this curve and the x-axis and the line x equals to -1. So x equals to -1, let's say this line is x equals to -1 and x equals to 3. So this is the entire region that we need to find, area of the shaded region. So in order to find the area, you will integrate the function x square plus 1 with respect to x dx. The lower limit would be -1, the upper limit would be 3. So when you integrate this function, you get x cubed over 3 plus x, and then just apply the limits. First apply the upper limit, then substitute the lower limit, then evaluate the answer for it. Square units or unit square, same thing. So 40 over 3 is the exact area of this function when integrated from -1 to 3. So basically this is the area bounded by the curve and the x-axis and the line x equals to -1 and the line x equals to 3. Okay, so in this question you need to find the area bounded by the following curve and the x-axis. So let's just give a quick sketch so that you can have an idea what is the region that we are looking for. This is a quadratic equation with roots as 0 and -2. It's a minimum curve. So a quick sketch would look something like this, where this equation is y equals to x times x plus 2. This point is -2, this is 0, and you are being asked to find the area bounded by this curve and the x-axis. So this is the region that we are looking at. This is our required region, and we need to find the area of this region. So since it's below the x-axis, when you integrate this function and plug in the limits from -2 to 0, you will get a negative value. That negative value implies that you have a region below the x-axis. So let's begin with the working. I have to integrate x times x plus 2 dx from -2 to 0. So if you just multiply that, x square plus 2x from -2 to 0 dx. Now integrate the function, and the limits are from -2 to 0. Simplify the expression if possible. Plug in the upper limits first. So when you plug in 0, the entire expression would become 0. Minus, then plug in the lower limits. So -2 cube is -8 over 3 plus 4. When you simplify this, you get -4 over 3. Now we know that area cannot be negative. So area is 4 over 3 square units or unit square. But this negative area implies that the region that we are looking at is below the x-axis. Now let's look at a question in which you are being asked to find the area but that shaded area or the required area is above and below the x-axis at the same time. So for those questions such as this, you need to find the area bounded by the curve y equals to x plus 1 times x minus 2 and the x-axis and the line x equals to 3. So if you just give a quick sketch, you will get to know how this function looks like and what is the shaded region that we are looking for. So y equals to x plus 1 x minus 2 is a quadratic equation with roots as -1 and 2. -1, 2. You need to find the area bounded by this curve and the x-axis and the line x equals to 3. So line x equals to 3 would be here. So the required region will now be this, because this is the area bounded by the curve and the line and the x-axis, and the curve, the x-axis and the line x equals to 3. So you need to find this, the area for the total required region. Now for such questions, you need to do the integration process in 2 steps. First of all, you will integrate the function from -1 to 2 with the lower limit as -1 and the upper limit as 2, and then you will integrate the function from 2 to 3. Okay, so let me call this region A, this region B, but the integration of a function would really be the same. So the function is, if you multiply this x plus 1 times x minus 2, you get x square minus x minus 2. Now you need to integrate the function to get the area. So the area integration would be x cube over 3 minus x square over 2 minus 2x. I'm just writing a constant of integration over here, but when we will plug in the limits, we don't need to write this constant of integration. अच्छा जी, तो in order to find the area A, by looking at the sketch, I know for the fact that region A would be, the integration of region A would be a negative value. Okay, so area of A would be to integrate x. Okay, so you have already integrated it, so this time you just need to apply limits. X cube over 3 minus x square over 2 minus 2x. The lower limit would be -1, the upper limit would be 2. When you plug in the upper limit, you get 8 over 3 minus 2 negative 4 minus the lower limit, which is minus 1 over 3 minus half plus 2. So simplify this and the answer evaluated to be -9 over 2. Now this -9 over 2 is just telling you that the area is below the x-axis. The area itself for A is 9 over 2 units square. Now if you do the same thing for B, you already have the integrated function as x cube over 3 minus x square over 2 minus 2x. The lower limit would be 2 and the upper limit would be 3. So just plug in the values. So total area is the area of region A plus the area of region B. So 9 over 2 plus 11 over 6 is 19 over 3 units square. That's your final answer. So let's look at the concept of finding the area bounded by two curves now. Visualize this as you have a curve and you have another curve. It can be a straight line as well. And you need to find the area bounded by the two curves. So the area bounded by the two curves can be found by subtracting the equation of a lower curve from the upper curve and then integrating them from A to B. Now what are these are the intersection points. The lower limit of the intersection point, one of the intersection point can be regarded as a lower limit, and the x coordinate of the another intersection point can be regarded as a upper limit. So when you would have you can say that this complete region, area bounded by the line and the x-axis, would be this, right? The entire region. And the area bounded by this curve and the x-axis would be this. So you can integrate them separately as well and then subtract the area to get the shaded region or this shaded region. Or you can just subtract the equation of a lower curve from the upper curve and integrate it, because the limits are going to be the same for both, which are the intersection points of the line and the curve. So let's look at this question. You need to find the area bounded by the curve y equals to x square and the line y equals to x. So you need to have an idea about which one is the upper curve and which one is the lower curve. So y equals to x square looks like this, and y equals to x की line would look something like this. ठीक है. So basically, I know the sketch is not that great, but you need to find this area. This is your upper curve and this is your lower curve. ठीक है. This is your lower curve. So you can do the integration process in one step. First of all, let's find the limits. So for the limits, we are looking at the points of intersection. So you can solve them simultaneously. So one of the x coordinate of the intersection point is 0 and the other point of intersection is 1. So in order to find the area, you need to subtract the two equations, upper curve minus lower curve, then integrate it from 0 to 1 and integrate it with respect to x-axis. So the integration of x would be x square over 2, integration of x square would be x square over 3. The lower limit is 0 and the upper limit is 1. When you plug in the limits, you get 1 over 2 minus 1 over 3, and when you place 0 you get 0. So the area is 1 over 6 unit square. You would have gotten the same answer if you would have done this in two steps. First find the area bounded by the upper curve and the x-axis, and then find the area by the lower curve and the x-axis, and then subtract them. So this would result also in the same area. Alright, so the next concept is to find the area bounded by the curve and the y-axis this time. So imagine you have a curve and you need to find the area bounded by this curve and the y-axis from these limits from a to b. So this is the shaded region that we are looking at. But in order to find this area through the integration process, you want to make sure that the function is in terms of x. What I mean by function in terms of x is when you will have the equation y equals to something, you need to make x the subject. So if you look at this example, find the area bounded by the curve y equals to x cube, the y-axis and the line y equals to -1 and y equals to 8. So this means y equals to x cube would look something like this. ठीक है, y equals to -1 is this line and y equals to 8 is this. So -1, 8. So the shaded region is basically this part and this part. So these are the two shaded regions. Acha. Now since one is on the right side and one is on the left side, the one with the left side of the y-axis this time would be a negative value. So again you have to integrate it in two parts. But सबसे पहले what you need to do is to make x the subject. You know that this equation was y equals to x cube. So if this equation of the curve is y equals to x cube, if you make x the subject, you get y cube root of y. So in order to find the area, you need to have a function in y. Okay, the function must be in y, dy, and the limits would be, you need to plug in the limits then. So let's say I need to do this integration process for area A. Okay, so for area A, the limits are from 0 to 8. I will have to integrate y raised to the power of 1 over 3 with respect to dy. So integration of y raised to the power 1 over 3 would be y 1 over 3 plus 1. So y raised to the power of 4 over 3 over 4 over 3, and the limits would be 0 to 8. So after plugging in the limits, you must get 12 units square. Similarly, for area B, you need to integrate the same function from -1 to 0. We are now doing part B. So integration would be same, but this time the limits are different, so the evaluated answer for the integration would be different. So when you plug 0 and then -1, you get -3 over 4. But you know that the area cannot be negative, so the area would just be 3 over 4 units square. Therefore, the total area would be the area of A plus area of B. So 12 plus 3 over 4, which is 12 whole 3 over 4 units square. Now if you would have integrated the function from -1 to 8 directly, then you would have not gotten the right answer, because then this part would have been subtracted from this answer. So it's always advisable to integrate the two portions differently using their respective limits. I hope this video was helpful for you. Thank you for watching this.